Today we're going to learn about the distributive property along with combining like terms. We've talked about the distributive property before, and it's defined as the product of a sum of two numbers or two terms. When you look at only variables, it makes it much easier to use the distributive property. The reason that we know that there is a product is because there's nothing between the a and the parentheses. So you're going to do a times b plus a times c. And remember, the most common way that we write that is not with the dots. We just put the variables side by side. You're distributing or giving out the a to every term inside the parentheses. Okay? So we're going to start out by applying the distributive property to write an equivalent expression. So that means they don't want us to solve it. You just write an equivalent or equal problem. So don't solve. Here we go. Yes, if we were going to solve it, we would not use the distributive property more than likely, but you could. You would add and then multiply by 2. Because, you do parentheses first. But if we're going to rewrite this using the distributive property, you're going to do 2 times 9 plus 2 times 5, which would be 18 plus 10. And then you don't solve it all the way, just leave it as an expression. Technically, I would also accept this as an expression too. Let's try another one. We're going to do 4 times 5. There's nothing beside the parentheses, remember. We're distributing the 4 to each term inside. So 4 times 5 plus, because there's a plus right there, and then 4 times 9. You could stop there, or you could say that it is 20 plus 4 times 9, 36. And do you see how the last expression that I'm circling does not look anything like this at first, while this one looks a little more like it. But it is showing you that we did the product of the sum of two numbers. Now we're going to look at ones with variables, because if we were going to use the distributive property, if we're going to use the order of operations, we would add what's in the parentheses first, but these aren't like terms, so we cannot add it. However, it is not simplified. Okay, so you want as few terms as possible. Now, usually, when you see simplify, you think of fractions. Well, not always with math in middle and high school. So, when you see simplify, as few terms as possible. Here we go. Alright, so like I said, we can add these because they're not like terms. There's nothing beside the 2 in the parentheses, so that tells us to distribute 2 times x, which is 2x. Bring down your plus. And then 2 times 2 is 4. Now you could do all of that in your head. If you need to write the steps that I said out loud, for example, if you need to, you could write 2 times 2 plus, 2 times x plus 2 times 2. Multiply these two, which would be 2x plus 2 times 2 is 4. I think you could skip this step, but if you need it, there's nothing wrong with writing it. Okay? Alright, well, let's look at the next one. If I were going to simplify this, I still look in my parentheses. Is there anything that I can do? These are x squares. This is a constant. So they are not like terms. You cannot subtract them. So now we look outside the parentheses. There's nothing between the 3 and the parentheses, so that lets you know it is the distributive property. And yes, there's a minus where we're all before we have pluses, but you can have a minus. When you multiply the constant of 3 times 2x squared, you only multiply the 3 times the coefficient. 3 times 2 is 6, and you just keep your x squared. And the reason that you just keep the x squared is because this says we have 3 of the 2x squared. So we have 2x squared, 2x squared, and 2x squared. If you add those together, 2, 4, 6, x squared. Repeated addition is shorter if you do the multiplication. Bring down your subtraction. I want to bring that. I want to write that a little further down. Hold on. So 6x squared minus this time, and then constant times constant. 3 times 3 is 9. X squares and 9s cannot be subtracted because they're not like terms, so you are finished. All right. Let's try one more together, and then I'm going to let you try by yourself. If we look at this problem, you still would try the order of operations. We have r plus 4 in the parentheses. There's nothing you can do with that. They are not like terms. So we have to look outside and see what would we do first. Well, this shows multiplication. We have addition and subtraction. Order of operations says to multiply or distribute first. So first we're going to distribute. Okay? 12 times r is 12r. Bring down your plus. 12 times 4 is 48. And then we just bring down everything else because we haven't done a thing with it yet. Now we look to combine like terms because we have a lot of terms. Alright, so start on the left. We have r's, not r's. Oh, we have 2 of those. So 12r minus 3r is 9r. Then you bring down your plus. And we have 2 constants. So those are like terms. We have 48. Remember the sign in front of the second term that is in your addition or subtraction problem. You have to include the sign with it. We already brought this one down, so that's why it's not in the box with 48. If you don't put the plus here, then you're not going to know whether to add or subtract. 48 plus 6 is 54. Are these like terms? Nope, we have r's and a constant, so we're finished. And that is our final answer. Do you see how we went from all of these terms down to 2? We have simplified the expression. Alright, I want you to pause the video and give the next one a try without me. When you come back, we'll compare answers. Welcome back. I am pretty confident that you were able to distribute the 8. We have 8x squares. 8 times x squared is just 8x squared. And then 9 times 8 is 72. There's a minus and bring it down. Bring down the x squared, and now we look for like terms. Now, don't forget, there is that imaginary 1 right here. They're not going to write that 1 for you. So that's going to mess you up for a little while until you get into the habit of knowing that this is really, it has a coefficient of 1. Okay? That will make these like terms because the x, and they are both to the second power. So the definition of like terms, remember, is same variable to the same power. 8x squared minus 1x squared is 7x squared minus 72. All right. Now, I'm going to let you pause the video once again and try number 7. We'll do number 8 together. I'll see you in a minute. Welcome back. Compare your answer to mine. If you didn't get the same thing, pause the video, go back and see what happened. The most common error is thinking that x is a like term for 3xy, or that 3xy is a like term for 8y. Remember, they have to have the exact same variables to the exact same exponents, and they don't. So that's why you cannot put them together. All right, I wanted to do number 8 with you because it's kind of intimidating. It's really long. But guys, just take it one step at a time. You don't even need to look at this part yet. Okay? Look inside your parentheses. Can we combine those? Nope, you cannot. So that tells us we're going to go ahead and distribute. Do 20 times C. Bring down your plus. And then 20 times 7G. Remember, multiply the constant and the coefficient. We have a big number now. Watch out. And what we're going to do next is we're going to forget about all of that. We're going to look at what we haven't even used. So you're going to bring down the plus 2. Oh, no, we're not. We're going to do plus. And then we're going to look inside our parentheses. Do we have any like terms in there or anything we should do? And the answer to that is no. There's no like terms, nothing we can simplify. So go ahead and distribute. 2 times C is 2C. Bring down that plus. 2 times 3G. 2 times 3 is 6G. Bring down the minus. And 2 times 5 is 10. All right, now let's look at all of that. Woo! We have 1, 2, 3, 4, 5 terms. That's a long problem. Don't panic, we're going to just work left to right. So we have some C's. These are not C's. These are C's. Not C's, not C's. So all we have to do is put 20C plus 2C together and get 22C. Bring down your plus. We have 140 G's, and these are 6 G's. Remember, you're having to box the sign in front of this. Is the second of the two like terms. That tells us to add or subtract. In this case, we're adding, so 140 plus 6 is 146 G. And the last term is hanging out here. We have a constant of 10. No other constants, so we are done. We have taken this really long problem and simplified it to 3 terms. All right, you should be getting pretty comfortable with these by now. So I want you to do the last 2 on your own. Pause the video and come back in a minute. Welcome back. For number 9, I hope you got 48. The most common mistake is saying that 14F minus 14F is a 0 and writing 0 plus 48 and stopping. You can go down from that. That is 2 terms. If you have 0 plus 48, that's 2 terms, and you can add those. 0 plus 48 is 48. So to eliminate that mistake, I just say, well, these cancel out, so I just mark them out and then only deal with the other terms. And the last one over here should be 13A plus 29. If you did not get that, pause the video, go back and look at my work and see where your mistake was. But just remember, guys, when applying the distributive property, the most common error that people make is they only distribute to the first term in the parentheses. You have to distribute to both terms, and there could be even 3 terms inside of the parentheses, like we had on number 8. There could be many terms in here, so this has to go to everything inside. I hope you now understand the distributive property and combining like terms, and I will see you next time.